Hi, this is Paul. We are doing Leetcode must-know interview questions, and today's challenge is convert sorted array to binary search tree. We're into a new category here in the must-know interview questions. It's divide and conquer. So I think this is going to be a shorter video today because this is rated as an easy problem. We've got a sorted array and we're going to convert it to a binary search tree. All right, well, divide and conquer. So if the array is sorted, then we can find, based on the length of the array, we can find the middle element, and the middle element will be the root of the tree. Okay. Now, if we use that as the root of the tree, then we have two subarrays. We have a subarray to the left of the root node. We have a subarray to the right of the root node. And we can just call the same argument or the same method again to create a balanced subtree for those two subarrays. So the subarray to the left of the root node, call the method on that, and that is going to become the left child of the root, and we'll call the method on the right, on the array elements to the right of the root node, and that will become the right child of the tree. And yeah, that's it. So let's see what this looks like. Well, actually, let's take a quick look at an example. These are, kind of too simple, really. But all right. So here's an input right here. It's sorted in non-descending order. So if we take the middle element, which is the 0, and say, all right, that's going to be the root. We take the elements to the left, which is -10 and -3, and say, all right, we're going to make that into a binary search tree, and we'll just attach it as the left child of the root. Two ways of doing that, depending on how you do your integer division, but it could look like this, -10, -3. It could look like this, -3, -10. Same thing on the right. Everything to the right of the 0 will be the right child of the root. So what does the tree node look like? It has a value, it has the left pointer, it has a right pointer. It has 3 constructors that we can use as needed. So let's do this. Sorted array to binary search tree. So what we're going to pass into the recursive function would be what are we going to call this? Well, what do they call the problem? Convert. Okay. Let's call it convert to tree. Now let's call it convert to BST. We'll pass in the array, which initially will be, well, you know what? That's not right. We'll pass in nums. But in each case, we'll pass in the array that we're interested in converting into a binary search tree. We will pass in the right and left with the start and end index that we want to process. So the start index is Well, for the first call, it's 0. We want to start at the first number, and we want to end at nums dot length minus 1. That is, we want to convert the whole array. Okay? What is that going? What is the recursive method is going to look like? So private, it'll return a tree node. We called it convert to BST. The input is going to be an integer array and 2 integers, which we'll call start and end. Okay? Base case, if start is greater than end, then we're done. Return null. Find the middle element. So int mid equals start plus end minus start, which is the length of the array. So length, wait a minute, let me think about this. Yeah, that's okay, we can do it that way. Start, we can do the divide by 2 like this. So it's start plus half the length. And that'll take us to the middle. And we'll create the root node. Tree node root equals new tree node, and the value is going to be array at mid, right? We have a constructor that'll do that, right? Yes. Okay. Create the left subtree. So root dot left equals let me just copy this and modify it. Root dot left equals convert to binary subtree. We are going to pass in the array ARR. We are going to pass in start, and we are going to pass in mid minus 1, because we want to create a binary search tree out of the array starting at the beginning of the array and ending at the element right before the element that we're using as the root. Okay? Do something very similar here for the right subtree. Convert to binary search tree, but we are going to start at one element beyond the element that we're using as the root, and we will go to the end. End is coming in right here. All right. And then return the root. I think that's it. Let's see. So the array comes in, so we're going to convert it to a binary search tree. This is the array that we're going to convert. This is where we're going to start. This is where we're going to end, the second parameter. So here's the recursive function. We send in the array, we send in the start index, we send in the end index. If start is greater than end, we can't go any further. So return null. That is, let's see. Okay. Yeah, if we get past that, actually, I'll talk a little bit more about how that could happen. But assuming it doesn't, what we're going to do is find the middle of the array and use that as the root. And then we will recursively take all elements to the left and convert them to a binary search tree and attach it to the attach it as the left child of the root. Same thing on the right, all the elements after the middle element, we'll convert those to a binary search tree and attach that as the right child. And we'll do that, recursively, as I said, as many times as we need to. This start equals end, start greater than end. How could that happen? Well, it would be something like example two, the second version of example 1 here. So let's say, well, we could still see that, right? If I move this over a little bit. All right. So here's the array, and we're now going to convert. We're going to convert the right subtree. So that means we're going to use the numbers 5 and 9. The indexes would be 0, 1, 2, 3, and 4. So start is 3, end is 4. Is start greater than end? No. All right. Well, what's the mid? What's the midpoint? Start is 3, end minus start. 4 minus 3 is 1 divided by 2. Integer arithmetic, that's 0. So mid is also 3. We're going to create a root node using the element at index 3, which is the number 5. And then we're going to create the left subtree. Convert to BST, array, start. Start is 3. Mid is also 3. Mid minus 1 is 2. If we call that, we're going to come in here and we're going to find that start is, in fact, greater than end. And so the 5 is not going to, well, it's going to have a null left subtree. That would be this empty space over here. When we create the right subtree, we will add the 9 right there. So let's try it. Compile error, missing return statement on line 19. All right. Sorry. There should be a return there. Okay. Let's try it again. All right. All good on the base cases. And submit. Oh man, excellent runtime. Why doesn't it there are not enough accepted admissions to show data? Well, that would surprise me. But okay. Let's see. All right, so that is the solution for converting a sorted array to a binary search tree. Hope you enjoyed it. Please feel free to subscribe, like, comment, and see you next time.